Hey everyone, tonight we're diving into something that will fundamentally change how you see reality itself. The universe isn't just big, it's incomprehensibly, mind-breakingly vast in ways that make our entire existence feel like a single grain of sand on an infinite beach. And here's the thing that'll keep you up at night. Everything we can see, every star, every galaxy, every cosmic wonder that's ever filled us with awe represents less than 1% of what's actually out there. So before we journey into this cosmic rabbit hole together, take a moment to like the video if you're ready to have your perspective completely shattered, and let me know in the comments where you're watching from and what time it is. There's something beautifully humbling about knowing we're all just tiny specks contemplating infinity together. Now settle in, maybe dim those lights, and prepare to confront the most staggering truth about our universe. When we talk about the size of the universe, we're not just discussing big numbers. We're talking about a reality so vast that our brains literally cannot process it. The observable universe, the bubble of space we can actually see, stretches roughly 93 billion light-years across. To put that in perspective, if you could drive a car at 60 miles per hour without stopping, it would take you 200 trillion years just to cross what we can observe. That's longer than Earth has even existed, longer than our solar system has been around, longer than complex life has walked this planet. But here's where it gets truly mind-bending. That observable universe, that incomprehensibly massive sphere of space containing hundreds of billions of galaxies, each packed with billions or trillions of stars, represents just a tiny fraction of the total universe. Think about that for a moment. Everything we've ever seen, studied, or dreamed about in space is basically nothing compared to what's really out there. The reason we can't see the whole universe isn't because our telescopes aren't powerful enough. It's because of something far more fundamental. Light, the fastest thing in existence, still has a speed limit. And that speed limit combined with the age of the universe creates an absolute boundary to what we can observe. It's like being trapped in a cosmic bubble, forever cut off from the infinite expanse beyond. Light travels at about 186,282 miles per second. That sounds impossibly fast, and it is by any human standard. But on cosmic scales, light crawls. It takes light 1.3 seconds to travel from the moon to Earth, 8 minutes from the sun, over 4 years from our nearest neighboring star, and 2.5 million years from the Andromeda galaxy, our closest galactic neighbor. This means when you look at Andromeda in the night sky, you're literally seeing it as it was 2.5 million years ago. You're looking back in time. The farther out we peer into space, the farther back in time we're seeing. Every telescope is essentially a time machine, showing us the universe as it was, not as it is. Since our universe is roughly 13.8 billion years old, there's a hard limit to how far light could have traveled to reach us. This creates what astronomers call the cosmic horizon, an invisible boundary beyond which we simply cannot see. No matter how advanced our technology becomes, no matter how powerful our telescopes grow, this fundamental limit cannot be broken. It's written into the very fabric of reality itself. But even this cosmic horizon isn't straightforward. The universe hasn't been sitting still while light has been traveling toward us. Space itself has been expanding, stretching, growing larger every second since the Big Bang. This means that objects we see at great distances have actually moved much farther away since the light we're observing left them. It's like trying to measure a balloon while someone's inflating it. The balloon keeps getting bigger even as you're taking your measurements. This expansion is why the observable universe is 93 billion light-years across, even though the universe is only 13.8 billion years old. The light from the most distant objects we can see has been traveling for nearly the entire age of the universe. But those objects have been carried away by cosmic expansion to distances far greater than the time their light has been traveling. Picture this cosmic expansion like raisins in rising bread dough. As the dough expands, the raisins get farther apart, but they're not moving through the dough. The dough itself is expanding, carrying the raisins along. Similarly, galaxies aren't flying through space away from each other. Space itself is growing, carrying galaxies along for the ride. This expansion creates something even stranger. There's actually a point beyond which light will never reach us, no matter how long we wait. Objects beyond a certain distance, currently about 19 billion parsecs away, are being carried away by expansion faster than their light can travel toward us. It's like trying to swim upstream in a river that's flowing faster than you can swim. You'll never make progress no matter how hard you try. The cosmic microwave background radiation represents the ultimate wall in our cosmic vision. This faint glow fills the entire sky and represents the afterglow of the Big Bang itself. But it's not actually from the Big Bang. It's from a moment about 400,000 years later, when the universe finally cooled enough to become transparent. Before this moment, the universe was filled with an opaque plasma soup. Photons, particles of light, couldn't travel freely because they kept bumping into electrons and other particles. It was like trying to see through a thick fog. The universe was essentially opaque to light. Then, as temperatures dropped, electrons combined with protons to form the first hydrogen atoms. Suddenly, the fog cleared, and light could travel freely for the first time. This moment is called recombination, and the light released then is what we see today as the cosmic microwave background. Originally, this radiation had a temperature of about 3,000 degrees Kelvin, glowing like hot metal. But 13.8 billion years of cosmic expansion has stretched this light, cooling it down to just 2.7 degrees above absolute zero. What was once visible light has been stretched into microwaves. This cosmic microwave background is absolutely everywhere. Unlike stars and galaxies that occupy specific locations, the CMB fills the entire sky. It's the oldest light we can ever hope to see, and it represents an absolute barrier. We cannot see beyond this point because before recombination, the universe was opaque. It's like trying to see through a brick wall. The information simply cannot reach us. The scale of what lies beyond our cosmic horizon is staggering. If cosmic inflation theory is correct, and most physicists believe it is, the total universe could be at least 100 sextillion times larger than what we can observe. That's a 1 followed by 23 zeros. To put this in perspective, if the observable universe was shrunk down to the size of a grain of sand, the total universe might be larger than Earth. Cosmic inflation explains how the universe became so incredibly large so quickly. In the tiniest fraction of a second after the Big Bang, space itself expanded exponentially. We're talking about expansion by a factor of 10 to the 30th power in approximately 1/trillionth of a trillionth of a trillionth of a second. It's an almost incomprehensible amount of growth in an almost incomprehensibly short time. This inflationary period solves several puzzles about our universe. It explains why the cosmic microwave background has almost exactly the same temperature in all directions. Without inflation, different regions of the early universe would have been too far apart to ever communicate and reach the same temperature. It's like finding that two pots of water on opposite sides of the world have exactly the same temperature without ever being connected. Inflation suggests that all these seemingly disconnected regions were once close together in a tiny space before inflation stretched them apart. They had time to reach thermal equilibrium before being separated by vast distances. It's an elegant solution to what seemed like an impossible coincidence. The geometry of our universe adds another layer of mystery to its total size. Recent measurements, particularly from the Planck satellite, suggest that space is flat. In a flat universe, parallel lines never meet, and the rules of ordinary geometry that we learned in school apply everywhere. a flat universe could potentially be infinite in size. But here's the catch. Even if the universe is infinite, we can only ever see a finite portion of it. Our observable universe would be like a small sphere floating in an infinite ocean. No matter how long we wait, or how advanced our technology becomes, there will always be infinite regions forever beyond our reach. If the universe is finite instead of infinite, it might be shaped like a hypertorus, a complex four-dimensional shape that loops back on itself. In such a universe, traveling far enough in one direction would eventually bring you back to your starting point, like walking around the surface of a sphere. But even if this is the case, calculations suggest the universe would have to be at least 250 times larger than our observable portion. The matter and energy content of our observable universe is mind-boggling in its own right. The total mass of ordinary matter, the stuff that makes up stars, planets, and us, is approximately 1.46 times 10 to the 53rd power kilograms. That's a 14 followed by 52 zeros. It's a number so large that it becomes meaningless to our everyday experience. But ordinary matter makes up only about 5% of the total energy content of the universe. 27% is dark matter, mysterious invisible stuff that outweighs ordinary matter by more than 5 to 1. And 68% is dark energy, an even more mysterious force that's accelerating the expansion of the universe. This means that 95% of our universe consists of things we don't understand. Dark matter reveals itself only through its gravitational effects, bending light and holding galaxies together. Dark energy pushes space apart, making the universe expand faster and faster. Together they dominate the cosmic budget, making ordinary matter a tiny minority in its own universe. Recent research is beginning to challenge our understanding of dark energy. Some scientists now suggest that the acceleration of cosmic expansion might be slowing down, or that dark energy itself might be evolving over time. Others propose that dark energy might not exist at all, and that what we interpret as accelerating expansion is actually an illusion created by the uneven distribution of matter throughout space. The possibility that our understanding of cosmic expansion is fundamentally wrong adds yet another layer of uncertainty to questions about the universe's total size. If dark energy is changing, or if it doesn't exist as we currently imagine, then our models of cosmic growth and the relationship between the observable and total universe might need complete revision. What makes this cosmic mystery even more profound is that the universe appears to be accelerating its expansion. 9 billion years after the Big Bang, something caused cosmic expansion to speed up rather than slow down. This acceleration means that galaxies beyond our current cosmic horizon are racing away from us ever faster, making the observable universe a shrinking fraction of the total cosmos. In the far future, this acceleration will have dramatic consequences. Objects that we can see today will eventually disappear beyond our cosmic horizon forever. Future astronomers billions of years from now will inhabit an increasingly empty-looking universe, with fewer and fewer galaxies visible to them. They'll live in cosmic isolation, cut off from the vast majority of cosmic history and structure. This raises profound questions about our place in the cosmic order. Are we living in a special time when the universe is visible and interesting, or is our current view just one moment in a much grander story? The universe we observe today might be vastly different from what past or future observers would see, making our cosmic perspective both precious and temporary. The search for the universe's true size continues to drive cutting-edge research and technological development. Future space missions, like the Nancy Grace Roman Space Telescope and the European Space Agency's Euclid mission, will map the three-dimensional structure of the universe in unprecedented detail. These observations might help us better understand dark energy, cosmic expansion, and the relationship between what we can see and what actually exists. But even with these advances, fundamental limits will remain. The cosmic microwave background will always represent an absolute barrier to direct observation. The cosmic horizon will always limit how far we can see. And the accelerating expansion of space will continue to carry distant regions beyond our reach. These limitations force us to confront a humbling reality. We might be living in a universe so vast that calling it infinite isn't hyperbole, it's potentially literal truth. And if that's the case, then somewhere out there, beyond our cosmic horizon, entire regions of space exist that contain exact duplicates of our galaxy, our solar system, maybe even exact copies of Earth and everyone on it. This isn't science fiction speculation. It's a mathematical consequence of infinite space combined with finite arrangements of matter. In an infinite universe, every possible configuration of atoms must repeat eventually. The number of ways to arrange matter within a region. The size of our observable universe is enormous but finite. Given infinite space, these arrangements must repeat, creating cosmic twins of everything we know. The implications are staggering. If the universe is truly infinite, then there are countless versions of you reading these words right now, countless Earths orbiting countless suns, countless civilizations wondering about the same cosmic questions that keep us awake at night. Some of these cosmic duplicates might be nearly identical to us, while others might have subtle differences, like a world where you chose a different career or a different planet where life evolved along completely different paths. But here's what makes this even stranger. These duplicate regions aren't just theoretical possibilities scattered randomly through infinite space. According to our best calculations, if the universe is infinite and matter is distributed roughly evenly, then a perfect duplicate of our observable universe should exist approximately 10 to the power of 10 to the power of 118th meters away. That's a distance so large that writing it out would require more digits than there are atoms in our observable universe. To put this cosmic duplication in perspective, imagine you're looking at a massive library that contains every possible book that could ever be written. Most of these books would be complete gibberish, random arrangements of letters that mean nothing, but hidden among the chaos would be perfect copies of every great work of literature. Every scientific discovery, every love letter ever written, and every conversation you've ever had. An infinite universe with finite arrangements works the same way. Most regions would be empty space or chaotic arrangements of matter, but exact duplicates of our cosmic neighborhood must exist somewhere in the infinite expanse. This cosmic repetition extends beyond just physical arrangements. If consciousness and thought patterns are products of specific neural configurations, then in an infinite universe, there must be exact duplicates of every mind that has ever existed. Somewhere beyond our horizon, perfect copies of Einstein are discovering relativity again. Perfect copies of Shakespeare are writing Hamlet, and perfect copies of you are contemplating these same mind-bending possibilities. The structure of space on the larger scales reveals patterns that hint at even grander mysteries. When astronomers map the distribution of galaxies across billions of light years, they find something unexpected. Matter isn't spread evenly through space. Instead, it forms a cosmic web with massive filaments of galaxies stretching across hundreds of millions of light years, separated by enormous voids that contain almost nothing. These cosmic voids are vast beyond comprehension. Some span hundreds of millions of light years across, regions so empty that if Earth were placed in the center of one, the nearest galaxy would be barely visible even with our most powerful telescopes. To an observer in such a void, the universe would appear almost completely empty, a few faint smudges of light scattered across an otherwise dark sky. The cosmic web structure suggests that our observable universe might be just one small section of a much larger pattern. If we could zoom out far enough, our entire observable universe might appear as just one knot in an infinite cosmic web, with structure continuing on scales that dwarf even our grandest measurements. Recent discoveries have found structures so large they challenge our basic assumptions about cosmic uniformity. Astronomers have detected galaxy formations stretching across billions of light-years, ring-like structures over 1 billion light-years in diameter, and walls of galaxies that span significant fractions of our observable universe. These structures are so large they shouldn't exist according to our current understanding of how the universe evolved. The discovery of such massive structures raises profound questions. If the universe contains patterns on scales approaching the size of our observable region, what does this say about the total size and organization of the cosmos? Are we seeing hints of structure that extends far beyond what we can observe? Could our entire observable universe be just one small feature in a cosmic pattern of unimaginable scope? Time itself becomes strange when we consider the universe's vast scale. In different regions of space, time passes at different rates due to the effects of gravity. Clocks in the dense centers of galaxy clusters tick slightly slower than clocks in the vast empty voids between galaxies. Over cosmic timescales, these differences add up. A clock placed in one of the great cosmic voids would have ticked billions of years more than an identical clock placed in our galaxy. This means that different regions of the universe have experienced different amounts of time since the Big Bang. In the vast empty regions, more cosmic time has passed, allowing more expansion, more cooling, and potentially more evolution. The universe isn't just big in space, it's also stretched across time in ways that make simultaneity itself a relative concept. The farther we look into space, the more we realize how little we actually know. Every new discovery seems to reveal that the universe is stranger, larger, and more complex than we previously imagined. The cosmic microwave background shows tiny fluctuations that seeded the formation of all cosmic structure. But we don't understand what caused these fluctuations. Dark matter shapes the evolution of galaxies, but we have no idea what it's made of. Dark energy dominates the universe's energy budget, but we don't know what it is or why it exists. These mysteries hint at physics beyond our current understanding. The universe's vast scale might be trying to tell us something fundamental about the nature of reality itself. Perhaps our models of space, time, matter, and energy are incomplete approximations that work well in our small corner of the cosmos, but break down on grander scales. Some physicists propose that what we call the universe might actually be just one bubble in an infinite multiverse, with each bubble containing its own laws of physics, its own values for fundamental constants, and its own evolutionary history. In this scenario, our observable universe wouldn't just be a small part of something larger, it would be one reality among infinite others, each potentially as vast and complex as our own. The multiverse concept pushes the boundaries of scale beyond anything we've discussed. If multiple universes exist, each potentially infinite in its own right, then the total scope of reality becomes truly limitless. Our universe, vast as it is, would be just one note in an infinite cosmic symphony, one thread in a tapestry of realities that extends forever in directions we can't even imagine. But even without invoking multiple universes, the scale of our single cosmos remains overwhelming. The observable universe contains an estimated 2 trillion galaxies, each home to hundreds of billions of stars. Many of these stars have planets, and some of these planets might harbor life. The numbers become so large that even conservative estimates suggest millions or billions of worlds with life exist within our cosmic horizon. If life is common on cosmic scales, then the universe beyond our observation might teem with civilizations, some younger than ours, others billions of years more advanced. Across the vast expanses of space, countless species might be asking the same questions we're asking, looking out at their own cosmic horizons and wondering what lies beyond. The possibility of advanced civilizations scattered throughout the cosmos adds another layer to our cosmic isolation. Even if millions of intelligent species exist within our observable universe, the vast distances between stars make communication or travel nearly impossible. Each civilization exists in its own island of space, separated by distances so vast that even light signals take thousands or millions of years to cross the gaps. This cosmic loneliness might be the price of living in a universe so large. The same vast scale that creates infinite possibilities also ensures that most of these possibilities remain forever isolated from each other. We might share the cosmos with countless other conscious beings, but the universe's immense size keeps us separated by unbridgeable gulfs of space and time. Yet this isolation also makes our existence more precious. In a universe so vast that it defies comprehension, the fact that matter organized itself into forms capable of contemplating cosmic scale represents something extraordinary. We are the universe becoming aware of itself, consciousness emerging from cosmic evolution to ponder the very questions of scale and meaning that define our existence. The search for cosmic truth continues to drive human exploration and discovery. Every new telescope reveals more distant galaxies, more complex structures, more hints about the universe's true nature. But with each discovery, the mystery deepens rather than resolves. The more we learn about cosmic scale, the more we realize how much we don't know. Future generations might develop technologies that allow them to probe deeper into space and time, perhaps finding new ways to test theories about the universe's total size and structure. But they'll always face the same fundamental limits that constrain us. Light speed, cosmic expansion, and the finite age of the universe create boundaries that no technology can overcome. This means that questions about the universe's true size might remain forever unanswered. We might never know whether space is infinite or finite, whether our observable universe represents a tiny fraction or a significant portion of total reality, whether we're alone or surrounded by cosmic companions, forever hidden beyond our horizon. But perhaps the questions themselves are more important than the answers. In contemplating cosmic scale, we confront our own place in the grand scheme of existence. We realize that despite our cosmic insignificance, we represent something remarkable, patterns of matter and energy that have become complex enough to wonder about their own origins and context. The universe's age itself becomes a cosmic constraint that shapes everything we can possibly know about reality. 13.8 billion years might seem like an eternity from our human perspective. But on cosmic scales, it's barely a moment. This finite age means that no matter how infinite space might be, we're fundamentally limited by time. Light from the most distant regions simply hasn't had enough time to reach us yet. Think about this temporal boundary for a moment. Even if the universe is infinite and filled with countless wonders, most of it remains invisible to us, not because it's too far away, but because it's too young. The light carrying information about these distant realms is still traveling through space, racing toward us at maximum speed, but still billions of years away from arrival. In a sense, we're living in a cosmic waiting room, surrounded by information that exists but hasn't reached us yet. This creates one of the strangest aspects of cosmic observation. When we look at the most distant galaxies visible to our telescopes, we're seeing them as they were when the universe was just a few 100 million years old. These galaxies appear young, small, and chaotic, because that's what they actually were at the time their light left them. But today, after 13 billion years of evolution, These same galaxies might be massive, mature systems filled with countless stars and planets. The gap between what we observe and what actually exists right now spans the entire history of cosmic evolution. Every distant galaxy we see is a fossil, a preserved moment from the universe's youth. The farther we look, the younger the universe appears, until we reach the cosmic microwave background, where we're seeing the universe as it was when it first became transparent. This temporal displacement means that our view of the cosmos is fundamentally historical rather than contemporary. We're not seeing the universe as it is, but as it was across billions of years of cosmic time. It's like trying to understand a vast city by looking at photographs taken at different times over decades, with the most recent photos showing only the nearest neighborhoods and the oldest photos revealing the entire urban landscape as it existed long ago. The cosmic web structure we observe today represents billions of years of gravitational evolution. Dark matter began clumping together shortly after the Big Bang, creating an invisible scaffolding that guided the formation of the first stars and galaxies. Over time, this scaffolding grew into the magnificent cosmic web we see today, with galaxies strung along dark matter filaments like pearls on invisible strings. But here's what makes this even more mind-bending. The cosmic web we observe stretching across billions of light years might be just the beginning of structure on even grander scales. If the universe is truly infinite, then the patterns we see in our observable region might repeat and connect with similar structures far beyond our cosmic horizon. Imagine zooming out from our observable universe until it becomes just a point of light, then continuing to zoom out until you see countless other points, each representing a region as vast as everything we can observe. These regions might be connected by structures so large that our entire observable universe appears as just one small feature in a cosmic pattern of incomprehensible scope. The mathematics of infinite space suggests that if the universe contains patterns on the scale we observe, then these patterns must continue indefinitely. The cosmic web filaments stretching across our observable universe might connect to other filaments extending far beyond our horizon, creating a network of structure that spans distances we can't even conceptualize. Recent computer simulations of cosmic evolution hint at this possibility. When scientists model the growth of structure in regions much larger than our observable universe, they find that the cosmic web continues to grow and connect across ever larger scales. These simulations suggest that what we see might be just one small section of an infinite cosmic tapestry. The implications stagger the imagination. If these models are correct, then somewhere beyond our cosmic horizon, vast streams of galaxies are flowing along dark matter superhighways that dwarf anything we've observed. Cosmic structures so large that light takes billions of years just to cross them might be common features of the greater universe, invisible to us only because of our limited perspective. Dark matter adds another layer of mystery to these cosmic scales. This invisible substance outweighs ordinary matter by more than 5 to 1, yet we can only detect it through its gravitational effects. Dark matter halos surrounding galaxies can extend far beyond the visible stars, creating invisible structures that might connect neighboring galaxies across vast distances. On the largest scales, dark matter forms an invisible cosmic web that guides the flow of ordinary matter throughout the universe. This dark scaffolding might extend far beyond our observable region, creating connections and structures that we can't see, but that profoundly influence the evolution of everything we observe. The nature of dark matter itself remains one of the deepest mysteries in science. It might consist of exotic particles that barely interact with ordinary matter, or it might represent something even stranger, a modification of gravity itself on cosmic scales. Whatever dark matter turns out to be, its presence throughout the universe means that the majority of cosmic structure remains completely invisible to us. Dark energy presents an even greater puzzle. This mysterious force drives the accelerating expansion of space, pushing galaxies apart at ever-increasing rates. But we have no idea what dark energy actually is or why it exists. It might be a property of space itself, a quantum field permeating all of reality, or something even more exotic that we haven't imagined yet. The discovery that cosmic expansion is accelerating rather than slowing down revolutionized our understanding of the universe's fate. Instead of eventually collapsing back in on itself or expanding at a steady rate, the universe appears destined for an ever-accelerating expansion that will eventually tear apart all cosmic structures. This acceleration has profound implications for the relationship between the observable and total universe. As expansion speeds up, the cosmic horizon doesn't grow as quickly as it would in a steadily expanding universe. In fact, in the far future, the cosmic horizon will actually begin to shrink as objects disappear beyond our ability to observe them forever. The cosmic horizon represents more than just an observational limit. It's a fundamental boundary that separates the knowable from the unknowable. Beyond this horizon lies not just more space and more galaxies, but potentially entirely different physics, different constants of nature, maybe even different dimensions of reality. Some theories suggest that the universe might have regions where the fundamental forces of nature have different strengths. In some areas, gravity might be stronger or weaker, electromagnetic forces might behave differently, or the nuclear forces that hold atoms together might have entirely different properties. These regions would create cosmic environments so alien that life as we know it couldn't exist. If such regions exist beyond our cosmic horizon, then the universe contains not just more of what we see, but entirely different types of reality. Zones where matter behaves according to different rules, where the laws of physics themselves might be unrecognizable to us. The total universe might be not just larger than we imagine, but fundamentally more diverse and strange. The concept of cosmic inflation adds yet another dimension to these possibilities. If inflation occurred as most physicists believe, then our observable universe represents just one small bubble of space-time that happened to undergo this explosive expansion. But inflation might have occurred differently in other regions, creating bubbles with different properties, different physics, different possibilities for the emergence of structure and complexity. In this scenario, what we call the universe might actually be just one region in an infinite landscape of cosmic bubbles, each with its own characteristics, its own evolution, its own potential for giving rise to stars, planets, and life. Some bubbles might be larger than ours, others smaller. Some might have more dimensions of space, others fewer. Some might contain types of matter and energy that don't exist in our region. This inflationary multiverse concept pushes the boundaries of cosmic scale beyond anything we've discussed. If multiple cosmic bubbles exist, each potentially as large as our observable universe or larger, then the total scope of reality becomes truly infinite in both space and possibility. But even within our single bubble, our single universe, the implications of infinite space remain staggering. Every possible arrangement of matter that can exist within the laws of physics must exist somewhere in an infinite cosmos. This means that beyond our cosmic horizon, nature has experimented with every conceivable form of organization, every possible pathway of evolution, every potential outcome of cosmic development. The universe becomes not just a place, but a vast library of possibilities, containing every story that physics allows to be written. Most of these stories would be brief and unremarkable, random arrangements of particles that quickly decay into simpler forms. But scattered throughout the infinite expanse would be regions of extraordinary complexity and beauty, cosmic neighborhoods that have achieved forms of organization we can barely imagine. Some regions might have given rise to civilizations millions or billions of years more advanced than our own. These cosmic cultures might have learned to harness the energy of entire galaxies, to manipulate matter and energy on scales that make them indistinguishable from natural forces, to explore and understand aspects of reality that remain completely hidden from us. Other regions might contain forms of life based on entirely different chemical foundations, evolving in environments so alien that they would appear more like natural phenomena than living beings to our eyes. Silicon-based life in the cores of stars, plasma-based organisms in the magnetic fields of neutron stars, quantum mechanical entities existing in the vacuum of space itself. The possibilities become endless when we consider the full scope of an infinite universe. Every scientific discovery we make, every technology we develop, every work of art we create, every thought we think, might have countless parallels scattered throughout the cosmic expanse. But they would also be accompanied by variations and alternatives that push the boundaries of what we consider possible. This infinite repetition and variation means that the universe contains not just duplicates of our reality, but endless experiments in alternative realities. Worlds where history unfolded differently, where evolution took different paths, where the constants of physics have slightly different values that led to entirely different outcomes. The search for extraterrestrial life takes on new dimensions when we consider these cosmic scales. Within our observable universe alone, the number of potentially habitable planets reaches into the billions or trillions. But in an infinite universe, life becomes not just probable, but inevitable, arising in countless forms across countless worlds. Yet the vast distances between stars ensure that most of these civilizations remain forever isolated from each other. Even signals traveling at light speed would take thousands, millions, or billions of years to cross the gaps between stellar systems. By the time a message reaches its destination, the civilization that sent it might have evolved beyond recognition or disappeared entirely. This cosmic isolation creates a profound paradox. In a universe teeming with life and intelligence, most conscious beings remain fundamentally alone, separated by distances so vast that meaningful communication or contact becomes impossible. Each civilization exists in its own bubble of space and time, aware that others must exist but unable to reach them. The loneliness of cosmic scale affects not just potential civilizations, but the nature of knowledge itself. Each region of the universe develops its own understanding of reality based on what it can observe from its particular location and time. Different cosmic neighborhoods see different portions of the cosmic web, different arrangements of galaxies, different aspects of cosmic history. This means that complete knowledge of the universe might be impossible even for the most advanced civilizations. No matter how sophisticated their technology becomes, no matter how far they travel or how long they exist, they will always be limited by the fundamental constraints of light speed and cosmic expansion. The universe keeps its deepest secrets not through active concealment, but through sheer scale. The information exists, scattered across infinite reaches of space and time, but no single observer can ever collect it all. Reality becomes not just large, but fundamentally unknowable in its totality. This unknowability doesn't diminish the value of cosmic exploration, but enhances it. Every discovery we make represents a precious fragment of cosmic truth, a small piece of the infinite puzzle that is existence itself. Our scientific endeavors become not just practical pursuits, but acts of cosmic archaeology, uncovering clues about the nature of reality from our tiny vantage point in the vast expanse. The tools we use to explore cosmic scale continue to evolve and improve. Future space telescopes will peer deeper into space and further back in time, revealing galaxies and structures that formed when the universe was even younger. Advanced computer simulations will model cosmic evolution on scales approaching the size of our observable universe, helping us understand how structure grows and connects across vast distances. But these technological advances will also reveal new mysteries and deeper questions. Each answer we find seems to generate multiple new puzzles. Each discovery opens doors to realms of ignorance we didn't even know existed. The universe appears designed to stay one step ahead of our understanding, always presenting new challenges to our cosmic curiosity. The philosophical implications of cosmic scale challenge our most basic assumptions about existence and meaning. In a universe so vast that our entire observable region might be essentially nothing compared to the total reality, questions about purpose and significance take on new dimensions. Some find cosmic scale humbling to the point of nihilism. If we're truly insignificant specks in an infinite expanse, if our entire civilization will eventually be forgotten in the cosmic dark, then what's the point of anything we do? Why does any human endeavor matter in the face of such overwhelming vastness? But others find cosmic scale inspiring rather than depressing. The fact that the universe became complex enough to produce beings capable of contemplating its own scale represents something extraordinary. In all the infinite expanse of space, in all the countless arrangements of matter and energy, consciousness represents a remarkable achievement of cosmic evolution. We are the universe waking up to itself, matter and energy, organized in such a way that it can ponder its own existence. Our ability to ask questions about cosmic scale, to feel awe at the vastness of reality, to seek understanding of our place in the grand scheme of things makes us partners in the cosmic story rather than mere observers of it. The universe's vast scale also puts our earthly concerns in perspective without necessarily diminishing their importance. Yes, our planet is tiny compared to cosmic structures, and our lives are brief compared to cosmic timescales. But this cosmic context can make our existence more precious rather than less meaningful. In a universe so large that most regions remain forever empty and dark, the emergence of life, consciousness, love, creativity, and wonder represents something miraculous. We exist in a cosmic oasis of complexity and meaning, a rare region where the universe has achieved something beautiful and significant. The search for cosmic truth becomes not just an intellectual pursuit, but a spiritual journey, a quest to understand our role in the vast cosmic story. Every scientific discovery connects us more deeply to the universe that gave birth to us. Every moment of cosmic wonder reminds us of our participation in something infinitely larger than ourselves. As we continue to push the boundaries of cosmic knowledge, we join an ancient human tradition of seeking to understand our place in the grand scheme of existence. From the earliest humans who looked up at the night sky and wondered about the lights they saw, to modern astronomers mapping the cosmic web across billions of light years, we participate in an unbroken chain of cosmic curiosity. This curiosity drives us to build bigger telescopes, develop more sophisticated theories, and ask deeper questions about the nature of reality. It connects us to the universe in the most profound way possible, through the quest for understanding that makes us uniquely human, illy human. The quest for cosmic understanding reveals something profound about the nature of knowledge itself. When we measure the cosmic microwave background, when we map the distribution of galaxies, when we calculate the age of the universe, we're not just gathering data. We're participating in a conversation that spans billions of years, a dialogue between conscious minds and the cosmos that created them. This conversation has practical implications that extend far beyond academic curiosity. Understanding cosmic scale helps us grasp our planet's place in the vast machinery of space and time. Earth sits in a relatively sparse region of our galaxy, orbiting a middle-aged star in an unremarkable spiral arm. Yet this seemingly ordinary location provides the perfect conditions for complex chemistry and stable evolution. The cosmic perspective also reveals the incredible rarity of our circumstances. Not only does Earth happen to orbit in the habitable zone around our star, but our solar system exists in a galactic environment that's neither too dense nor too empty, neither too young nor too old. We're positioned in a cosmic sweet spot that allowed billions of years of peaceful evolution. When astronomers study the cosmic web, they find that most regions of space are either too dense or too empty to support the kind of stable, long-term development that led to life on Earth. Dense regions experience too much radiation and gravitational disruption from nearby stars and black holes. Empty regions lack the heavy elements necessary for rocky planets and complex chemistry. Our location in the cosmic web places us in what scientists call a moderate density environment, where galaxies are close enough to provide enriched materials, but far enough apart to avoid destructive interactions. This cosmic real estate represents a tiny fraction of the total universe, making our existence not just improbable, but extraordinarily special. The elements that make up our bodies tell their own cosmic story. Every carbon atom in your DNA, every oxygen molecule you breathe, every iron atom in your blood was forged in the nuclear furnaces of stars that lived and died billions of years ago. We are quite literally made of star stuff, recycled stellar material that has been processed through multiple generations of cosmic evolution. This stellar recycling process requires vast amounts of time and space to work effectively. The first generation of stars contained only hydrogen and helium, the lightest elements created in the Big Bang. These massive early stars lived fast and died young, exploding as supernovas that scattered heavier elements throughout space. Subsequent generations of stars incorporated these elements, creating even heavier atoms through nuclear fusion and explosive stellar death. The process of building up the periodic table of elements through stellar evolution spans billions of years and countless stellar generations. The calcium in your bones might have been created in a star that died before our solar system was even born. The gold in your jewelry might have been forged in the collision of two neutron stars in a distant galaxy billions of years ago. This cosmic recycling connects us intimately to the vast scales of space and time we've been exploring. We're not separate from the universe looking in from the outside. We're made of the universe, temporary arrangements of cosmic materials that have organized themselves into patterns capable of consciousness and wonder. The realization that we're built from stellar debris adds new meaning to cosmic scale. When we look out at distant galaxies, we're seeing the foundries where our constituent atoms were created. When we observe stellar explosions, we're witnessing the processes that made our existence possible. The universe isn't just something we observe, it's something we participate in at the most fundamental level. This participation extends beyond our physical composition to our cognitive capabilities. The human brain, with its 100 billion neurons and trillion connections, represents one of the most complex structures known to exist anywhere in the observable universe. The fact that this biological computer can contemplate cosmic infinity suggests something profound about the relationship between mind and cosmos. Consciousness appears to be the universe's way of examining itself. Through human minds and potentially countless other forms of awareness scattered throughout space, the cosmos develops self-knowledge. We become the universe's eyes and thoughts, temporary focal points where cosmic evolution achieves self-reflection. The mathematical relationships we discover in nature hint at deep connections between mind and reality. The same geometric principles that govern the formation of galaxies also appear in the structure of atomic nuclei. The equations that describe quantum mechanics also predict the behavior of black holes. The mathematical constants that determine stellar evolution also show up in the chemistry of life. These universal mathematical patterns suggests that consciousness and cosmos might be more intimately connected than we typically imagine. Perhaps the universe tends toward complexity and awareness, not by accident, but as a fundamental feature of cosmic evolution. Perhaps mind represents not an unlikely accident, but an inevitable outcome of sufficient time and space. The search for extraterrestrial intelligence takes on new significance when viewed from this cosmic perspective. If consciousness represents a natural development of cosmic evolution, then we should expect to find evidence of intelligence throughout the universe. The question becomes not whether other minds exist, but how to recognize and communicate with them across the vast distances of space. Current searches for extraterrestrial intelligence focus primarily on radio signals and other electromagnetic communications, but advanced civilizations might use forms of communication we haven't yet imagined. They might encode messages in gravitational waves, manipulate stellar output to create artificial beacons, or use quantum entanglement to achieve instantaneous communication across any distance. The cosmic scale we've been exploring also affects how we think about the longevity of civilizations. On human timescales, our technological civilization seems permanent and ever-growing. But cosmic timescales reveal that even the most successful civilizations face ultimate limits imposed by stellar evolution, galactic dynamics, and universal expansion. Our sun will eventually exhaust its nuclear fuel and expand into a red giant, making Earth uninhabitable in about 5 billion years. The Milky Way will collide with the Andromeda Galaxy in about 4 billion years, dramatically reshuffling the galactic environment. The accelerating expansion of the universe will eventually carry distant galaxies beyond our reach, leaving future civilizations in an increasingly empty cosmos. These cosmic timescales put human concerns in perspective without diminishing their importance. Yes, our individual lives are brief compared to cosmic evolution, but they represent precious moments of awareness in the vast flow of space and time. Every human experience, every creative act, every moment of love or discovery adds something unique to the cosmic story. The ultimate fate of the universe itself remains uncertain, adding another layer of mystery to cosmic scale. If dark energy continues to accelerate expansion, the universe might end in a big rip, with space expanding so rapidly that it tears apart all structures from galaxies down to atoms. Alternatively, dark energy might decay or reverse, leading to a big crunch where the universe collapses back in on itself. Other possibilities include heat death, where the universe expands and cools until all energy is evenly distributed and no further work can be done, or cyclic models where the universe undergoes infinite cycles of expansion and contraction. Each scenario has different implications for the long-term survival of information, consciousness, and meaning in the cosmos. But even these ultimate questions about cosmic fate pale before the immediate reality of our current cosmic moment. We exist during a remarkable period in cosmic history, when the universe is old enough to have developed complex structures, but young enough that stars still shine brightly and galaxies remain visible across vast distances. Future beings living trillions of years from now will inhabit a much darker and emptier universe, where the cosmic microwave background has cooled to almost absolute zero and most stars have exhausted their fuel. They might look back on our current epoch as a golden age of cosmic visibility and wonder, a brief period when the universe revealed its secrets to conscious observers. This temporal perspective makes our current scientific endeavors even more precious. The cosmic measurements we make today, the images we capture of distant galaxies, the discoveries we achieve about the nature of reality represent unique opportunities that may never come again. We're documenting the universe during one of its most interesting and observable phases. The responsibility of cosmic awareness extends beyond pure scientific investigation to questions of preservation and transmission. How do we ensure that the knowledge we gain about cosmic scale and structure survives into the far future? How do we communicate our discoveries to potential civilizations that might emerge long after we're gone? Some scientists have proposed creating cosmic time capsules, information storage systems designed to survive for millions or billions of years. These archives might contain not just our scientific discoveries, but also records of human culture, art and philosophy, preserving the story of consciousness in our corner of the cosmos. The challenge of long-term information preservation reflects the broader cosmic context we've been exploring. Just as the universe contains vast scales of space that dwarf our local environment, it also encompasses timescales that make human history seem instantaneous. Successful communication across cosmic distances requires thinking not just about space, but about time, designing messages and storage systems that can survive the rise and fall of entire civilizations. The cosmic perspective also influences how we think about our responsibilities to future generations. The decisions we make today about environmental protection, technological development, and social organization will affect not just our immediate descendants, but potentially the entire future trajectory of consciousness in our region of the universe. If we represent one of the universe's experiments in self-awareness, then our survival and development carry cosmic significance. The failure of human civilization wouldn't just represent a local tragedy, but might eliminate one of the rare instances where the cosmos achieved the ability to understand itself. This responsibility extends to our exploration of cosmic scale itself. Every new discovery about the universe's size and structure adds to the total knowledge available to conscious beings. Our astronomical observations, our theoretical developments, our technological innovations, all contribute to the universe's growing self-knowledge. The instruments we build to explore cosmic scale become extensions of cosmic consciousness, artificial eyes and minds that can perceive wavelengths and distances far beyond human biological limitations. Radio telescopes detect signals from billions of light years away. Space-based observatories peer back to within a few 100 million years of the Big Bang. Computer simulations model cosmic evolution across scales from quantum to universal. These tools allow us to transcend the limitations of our local perspective and achieve something approaching a cosmic viewpoint. We can mentally zoom out from Earth to the solar system, to the galaxy, to the cosmic web, to the observable universe, gaining a sense of scale that no biological organism could achieve through direct experience. The ability to comprehend cosmic scale represents one of humanity's greatest intellectual achievements. Through mathematics, physics, and observational astronomy, we've learned to think beyond our everyday experience and grasp concepts that exist far outside the range of natural human perception. This cognitive achievement connects us to the cosmic processes that created us while simultaneously transcending them. We use brains built by biological evolution to understand cosmic evolution, employing minds shaped by terrestrial experience to comprehend universal principles, applying consciousness that emerged on one small planet to questions that span infinite space and time. The recursive nature of this cosmic understanding creates a strange loop where the universe studies itself through conscious observers who are themselves products of cosmic evolution. We're simultaneously inside the system we're trying to understand and separate from it through our ability to contemplate it objectively. This paradox of cosmic consciousness reflects the broader mysteries surrounding scale, existence, and meaning. The more we learn about the universe's vast scope, the more questions arise about our place within it. Each answer reveals new depths of mystery. Each discovery opens doors to realms of ignorance we didn't know existed. The journey toward cosmic understanding never reaches a final destination, because the universe itself continues to evolve and change. New structures form, old ones dissolve, The expansion of space creates new possibilities while eliminating others. We're not just studying a static cosmos, but participating in an ongoing cosmic story. Our role in this story remains unclear. Are we simply temporary arrangements of matter that happen to be aware of cosmic scale? Or do we represent something more significant in the universal narrative? Does consciousness serve a cosmic purpose, or is it merely an accidental byproduct of complex chemistry? The answers to these questions might lie beyond our current cosmic horizon, in regions of space and time we cannot yet observe. Future discoveries might reveal purposes and patterns we cannot currently imagine, connecting our local existence to cosmic processes operating on scales we haven't yet conceived. But uncertainty about ultimate cosmic purpose doesn't diminish the immediate value of cosmic awareness. The sense of wonder we feel when contemplating infinite space, the intellectual satisfaction of understanding cosmic processes, the spiritual connection we experience with the universe that created us, all represent intrinsic goods that justify our cosmic curiosity. The universe has given us the gift of consciousness and the opportunity to understand our cosmic context. How we use these gifts, what we discover about reality's true nature, and how we share our knowledge with others becomes part of the ongoing cosmic experiment in awareness and understanding. In reaching toward cosmic truth, we participate in something larger than our individual lives or even our species' existence. We join the universe's quest to know itself, adding our unique perspective to the growing cosmic conversation about existence, meaning, and the nature of reality itself. The vast scales of space and time we've explored tonight reveal that we live in a cosmos far stranger and more magnificent than our ancestors ever imagined. From the cosmic microwave background, marking the edge of our observational reach, to the infinite expanse that might stretch beyond our wildest calculations, we inhabit a universe that challenges our understanding at every scale. Yet perhaps the most mind-bending aspect of cosmic scale isn't what we can see, but what we can't. The observable universe, vast as it is, might represent less than 1% of total reality. Think about that for a moment. Everything we've discovered, every galaxy we've catalogued, every cosmic structure we've mapped, could be essentially nothing compared to what actually exists. This limitation isn't temporary. It's not something we can overcome with better telescopes or more advanced technology. The cosmic horizon represents an absolute boundary, written into the fundamental structure of reality itself. No matter how long we wait, no matter how sophisticated our instruments become, there will always be regions of the universe forever beyond our reach. The mathematics of this cosmic censorship are staggering. If inflation theory is correct, and most physicists believe it is, then the total universe could be at least 10 to the 23rd power times larger than what we observe. That's not just big, that's incomprehensibly, impossibly vast. If our observable universe were the size of a grain of sand, the total cosmos might be larger than the entire Earth. But even these numbers fail to capture the true scale of what we're discussing. In an infinite universe, the concept of size itself becomes meaningless. There's no such thing as the biggest possible region or the most distant point. Every finite measurement, no matter how large, represents exactly 0% of infinite space. This infinite possibility creates one of the strangest consequences of cosmic scale. In an infinite universe with finite arrangements of matter, every possible configuration must repeat. Not might repeat, must repeat. The laws of probability become laws of certainty when you have infinite space to work with. Somewhere beyond our cosmic horizon, there's another galaxy exactly like the Milky Way, another solar system exactly like ours, another Earth with another version of you, reading these exact words at this exact moment. Not a similar version, an identical one. Every atom in the same position, every thought following the same pattern, every choice leading to the same outcome, the distance to this cosmic twin is calculable. If matter is distributed roughly evenly throughout space, then a perfect duplicate of our observable universe should exist approximately 10 to the power of 10 to the power of 118th meters away. That's a number so large that writing it out would require more digits than there are atoms in everything we can see. But it gets stranger. In an infinite universe, there aren't just one or two copies of our cosmic neighborhood. There are infinite copies, infinite versions of you, living infinite variations of your life. Most would be nearly identical, differing only in tiny, meaningless details. But others would diverge more dramatically, representing alternate paths your life might have taken. This cosmic repetition extends beyond just physical structures to the patterns of consciousness itself. Every thought you've ever had, every decision you've ever made, every dream you've ever experienced has played out countless times across the infinite expanse. You're not unique in the universe. You're infinite. The implications challenge our most basic assumptions about identity and existence. If perfect copies of you exist throughout the cosmos, which one is the real you? Are they all equally real? Do they share your consciousness? Or does each copy experience its own separate stream of awareness? These questions push the boundaries of philosophy into realms where science and metaphysics become indistinguishable. The universe's infinite scale creates scenarios that our evolved brains simply weren't designed to comprehend. We exist in a cosmos so vast that it exceeds the limits of human understanding. Even the empty space between galaxies tells a story of cosmic scale that defies imagination. The great cosmic voids, regions where almost no galaxies exist, span hundreds of millions of light years. If Earth were placed in the center of one of these voids, the night sky would appear almost completely dark. Only a few faint smudges would be visible, distant galaxy clusters scattered like islands in an ocean of emptiness. To an observer in such a void, the universe would seem almost completely empty. They might conclude that their small collection of nearby galaxies represented the entire cosmos, never imagining the vast networks of structure that exist beyond their observational reach. Their cosmic perspective would be even more limited than ours, trapped in a region so empty that they couldn't perceive the larger patterns of cosmic architecture. These cosmic voids aren't random empty regions. They're integral parts of the cosmic web, the largest scale structure in the universe. The distribution of matter on these scales follows patterns that emerged from tiny quantum fluctuations in the first moments after the Big Bang. Microscopic variations in the density of space have grown over billions of years into the cosmic web we observe today. The cosmic web represents organization on scales that strain our ability to visualize. Galaxy filaments stretch across hundreds of millions of light years, connecting dense clusters through otherwise empty space. These filaments are the highways of the cosmos, channels along which matter flows and galaxies form. Between them lie the great voids, vast regions where expansion has stretched space so thoroughly that almost nothing remains. When astronomers map the cosmic web across billions of light years, they find patterns that repeat on ever larger scales. The same types of structures that exist in our local cosmic neighborhood appear to extend as far as we can see. This suggests that the organization we observe might continue far beyond our cosmic horizon, creating patterns of structure on scales we can barely imagine. Recent discoveries have revealed structures so large they challenge our understanding of cosmic evolution. Galaxy formations that stretch across billions of light years, ring-like patterns over 1 billion light years in diameter, walls of galaxies that span significant fractions of our observable universe. These structures are so massive they shouldn't exist, according to our current models of how the universe developed. The existence of such large-scale structures raises profound questions about the nature of cosmic evolution. If the universe can create patterns on scales approaching the size of our observable region, what does this say about the total organization of space? Are we seeing hints of cosmic architecture that extends far beyond what we can directly observe? Some scientists propose that our entire observable universe might be just one feature in a cosmic pattern of unimaginable scope. The structures we see stretching across billions of light years might connect to other structures beyond our horizon, creating networks of organization that span distances we can't even conceptualize. The search for such supercosmic structures pushes the boundaries of observational astronomy. Future surveys will map the distribution of galaxies across even larger volumes of space, looking for patterns that might reveal the universe's organization on the grandest possible scales. These observations might show us whether our cosmic neighborhood is typical or represents something unusual in the broader cosmic landscape. But even our most ambitious future surveys will be limited by the fundamental constraints we've been exploring. The cosmic horizon represents an absolute boundary that no observation can cross. We might map the cosmic web across our entire observable universe, but there will always be larger patterns beyond our reach. The accelerating expansion of space adds urgency to these cosmic observations. As dark energy continues to drive galaxies apart, structures that we can barely see today will eventually disappear beyond our cosmic horizon forever. We're living during a unique period in cosmic history when large-scale structure is visible across vast distances. Future astronomers billions of years from now will inhabit an increasingly empty-looking universe. The cosmic web that we observe today will have been stretched and thinned by expansion until only the nearest structures remain visible. They'll live in cosmic isolation, cut off from the vast networks of structure that define our current view of the universe. This temporal limitation makes our current cosmic observations even more precious. We're documenting the universe during one of its most interesting and observable phases. The images we capture of distant galaxy clusters, the maps we create of cosmic structure, the measurements we make of cosmic expansion represent unique records of a cosmic epoch that will never be repeated. The responsibility of cosmic documentation extends beyond pure science to questions of cultural and intellectual preservation. How do we ensure that future generations understand the cosmic context they've inherited? How do we communicate the scale and wonder of the universe to beings who might live in a much emptier cosmos? The challenge becomes even more complex when we consider the possibility of communicating across truly cosmic distances. If advanced civilizations exist in distant galaxies, they're observing the universe from completely different perspectives. Their cosmic horizon encompasses different regions of space, different collections of galaxies, different views of cosmic structure. These alien astronomers might have discovered cosmic patterns that remain completely invisible from our location. They might understand aspects of cosmic organization that we can't perceive because we're looking at the universe from the wrong angle or the wrong time. The total understanding of cosmic reality might require combining observations from countless different cosmic perspectives. This distributed nature of cosmic knowledge reflects the broader challenge of understanding reality on infinite scales. No single observer, no matter how advanced or long-lived, can ever perceive more than a tiny fraction of what exists. Complete knowledge of an infinite universe is mathematically impossible, even for beings with unlimited time and technology. Yet this fundamental limitation doesn't diminish the value of cosmic exploration. Every observation we make, every pattern we discover, every measurement we complete, adds to the growing database of cosmic knowledge. We're contributing to a universal project of cosmic understanding that might span countless civilizations across billions of years. The universe appears to be engaged in a vast experiment in self-awareness, using conscious observers scattered throughout space and time to gradually map its own structure and evolution. We're participants in this cosmic project, temporary focal points where the universe develops knowledge about itself. Our role in this cosmic awakening connects us to something far larger than our individual existence or even our species' survival. Through our scientific observations and theoretical insights, we're helping the universe understand its own nature. We're contributing to a growing cosmic consciousness that might eventually span galaxies and endure for billions of years. The tools we've developed to explore cosmic scale represent extensions of this universal self-awareness. Our telescopes become the universe's eyes, peering across vast distances to observe cosmic structure and evolution. Our computers become cosmic minds, processing vast amounts of data to reveal hidden patterns and relationships. Future generations will undoubtedly develop even more powerful tools for cosmic exploration. Space-based interferometers might achieve resolution sharp enough to directly image planets around nearby stars. Gravitational wave detectors might reveal cosmic collisions occurring billions of light-years away. Quantum sensors might detect subtle variations in the fabric of space-time itself. But even these advanced technologies will operate within the same fundamental constraints that limit us today. The speed of light sets an absolute limit on how quickly information can travel. The age of the universe determines how far back in time we can see. The acceleration of cosmic expansion determines which regions of space will remain forever accessible. These physical limits ensure that cosmic exploration will always involve mystery and uncertainty. No matter how advanced our technology becomes, there will always be regions of space and time beyond our reach. The universe will always retain secrets that no observer can uncover. This permanent mystery adds depth and meaning to cosmic exploration. We're not working towards some final answer or ultimate understanding. We're participating in an endless journey of discovery, each observation opening new questions, each answer revealing deeper layers of cosmic complexity. The universe rewards our cosmic curiosity with ever more intricate and beautiful revelations about its structure and evolution. The more we learn about cosmic scale, the more we appreciate the remarkable complexity and organization that characterizes reality on every level from quantum to cosmic. Our journey through cosmic scale tonight has revealed a universe far stranger and more magnificent than our ancestors could have imagined. We've explored distances so vast that light takes billions of years to cross them, structures so large that our entire observable universe might be just one small feature, and possibilities so numerous that every conceivable arrangement of matter must exist somewhere in the infinite expanse. We've discovered that the universe is not just big, but potentially infinite, not just old, but eternally evolving, not just complex, but organized on scales that challenge our deepest understanding of reality itself. We've learned that our cosmic perspective is fundamentally limited by the speed of light and the age of the universe, creating boundaries that no technology can overcome. Most importantly, we've realized that these cosmic scales don't diminish our significance, but enhance it. In a universe so vast that most regions remain forever empty and dark, the emergence of consciousness represents something extraordinary. We are the universe awakening to itself, temporary arrangements of cosmic material that have achieved the ability to contemplate cosmic infinity. The questions we've explored tonight about cosmic scale connect us to the deepest mysteries of existence. Why does the universe exist at all? Why is it organized the way it is? What role does consciousness play in cosmic evolution? How do we find meaning and purpose in the face of such overwhelming vastness? These questions don't have easy answers, and they might not have final answers at all. But the act of asking them, The effort to understand our cosmic context, the wonder we feel when contemplating infinite space, represent something profoundly valuable in their own right. We are cosmic explorers, using minds built from stellar debris to understand the universe that created us. We are participants in a cosmic conversation that spans billions of years, temporary voices in an ongoing dialogue between consciousness and cosmos. We are witnesses to cosmic beauty and complexity on scales that exceed our wildest imagination. The universe has given us the remarkable gift of awareness and the opportunity to understand our place in the vast cosmic story. How we use these gifts, what we discover about reality's true nature, and how we share our cosmic perspective with others becomes part of the universe's ongoing experiment in consciousness and understanding. Tonight's journey through cosmic scale reminds us that we live in a universe of infinite possibility and eternal mystery. Every time we look up at the night sky, we're peering into an abyss of space and time that extends far beyond our ability to comprehend. Yet somehow, impossibly, we exist within this vast cosmos as conscious observers capable of contemplating our own cosmic insignificance and cosmic significance simultaneously. The universe is big. Bigger than we can imagine, bigger than we can measure, bigger than we can ever hope to explore. But we're part of it, connected to it, made from it, and capable of understanding it in ways that make us partners in the cosmic story rather than mere spectators. In contemplating cosmic scale, we touch something infinite and eternal, something that connects our brief existence to the vast sweep of cosmic evolution. We become participants in the universe's quest to understand itself, contributing our unique perspective to the growing cosmic awareness that might represent the deepest purpose of existence itself. The cosmic microwave background that we've discussed represents more than just the edge of our observational reach. It's a snapshot of the universe at its moment of first transparency, frozen in time and stretched across the entire sky. When we analyze this ancient light, we're reading the universe's baby picture, examining the tiny fluctuations that would eventually grow into the cosmic web of galaxies and voids we see today. These fluctuations in the cosmic microwave background are incredibly small, variations in temperature of only a few millionths of a degree. Yet from these microscopic seeds, gravity has sculpted the largest structures in the known universe. It's like watching a barely visible ripple in a pond grow into a tsunami that reshapes entire continents. The precision of these early fluctuations suggests something profound about the universe's initial conditions. The variations aren't random noise but follow specific patterns that match our predictions about cosmic inflation. The universe appears to have been fine-tuned from its earliest moments to produce the complex structures we observe today. This fine-tuning raises deeper questions about why the universe has the particular properties it does. The fundamental constants of physics, the strength of gravity, the mass of elementary particles, the rate of cosmic expansion, all seem precisely calibrated to allow the formation of stars, galaxies, and eventually life. Change any of these values by even tiny amounts, and the universe might have remained a cold, empty expanse forever. Some scientists propose that we live in just one universe among countless others in an infinite multiverse, each with different physical laws and constants. In this scenario, we observe a life-friendly universe not because it was designed that way, but because we couldn't exist in any other type. It's a cosmic selection effect, where conscious observers can only emerge in universes capable of supporting complexity and awareness. The multiverse concept pushes cosmic scale beyond anything we've previously discussed. If multiple universes exist, each potentially infinite in its own right, then the total scope of reality becomes truly limitless. Our universe, vast as it is, would represent just one bubble in an infinite foam of cosmic possibilities. These parallel universes might operate according to completely different physical laws. Some might have more dimensions of space or different types of fundamental particles. Others might experience time flowing backward or have gravity that repels rather than attracts. The variety of possible universes could be literally infinite, encompassing every conceivable variation of physical reality. But even within our single universe, the implications of infinite space create mind-bending possibilities that challenge our understanding of identity and existence. If space extends forever and matter is distributed roughly evenly, then statistical mechanics demands that every possible arrangement of particles must occur somewhere in the cosmic expanse. This isn't just philosophical speculation. It's a mathematical consequence of infinite space combined with finite possibilities. The number of ways to arrange matter within any finite region is enormous, but not infinite. Given unlimited space, these arrangements must repeat, creating cosmic duplicates of every structure, every planet, every living being. The calculations are staggering. A perfect duplicate of our entire observable universe should exist at a distance of approximately 10 to the power of 10 to the power of 118th meters away. That's a number so incomprehensibly large that the human mind cannot process it. Writing out this number would require more digits than there are atoms in everything we can see. But the cosmic repetition doesn't stop with single duplicates. In an infinite universe, there must be infinite copies of our observable region, each containing infinite versions of Earth, infinite versions of humanity, infinite versions of you. Most of these cosmic twins would be virtually identical, differing only in the positions of a few atoms. Others would represent dramatic variations where history unfolded completely differently. This infinite multiplication of reality creates paradoxes that strain our concepts of personal identity and free will. If countless versions of you exist throughout the cosmos, making every possible choice and living every possible life, then what makes your particular existence special or unique? Are you the real version while the others are copies, or are all versions equally authentic? The question becomes even more complex when we consider the nature of consciousness itself. Does each cosmic duplicate possess its own separate stream of awareness, or do they all share some deeper level of identity? If consciousness can be copied exactly, what does that say about the nature of the self and the continuity of personal experience? These cosmic duplications extend beyond individual beings to entire civilizations and cultures. Somewhere in the infinite expanse, perfect copies of human history are playing out on countless Earths. The Renaissance happens again and again. The same scientific discoveries are made by the same individuals. The same works of art are created by cosmic twins of their original authors. But infinite space also allows for infinite variations on these themes. Worlds where Shakespeare wrote different plays, where Einstein discovered different theories, where history took completely alternative paths, while still maintaining the same underlying physical laws. Every possible story that could unfold within the constraints of physics must be told somewhere in the cosmic library. The concept of a cosmic library becomes more than metaphor when we consider infinite space seriously. The universe contains not just every book that has been written, but every book that could possibly be written. Every possible arrangement of letters and words exists somewhere, scattered across countless worlds and countless civilizations. Most of these cosmic books would be meaningless gibberish, random arrangements of symbols that convey no information. But hidden among the chaos would be perfect copies of every great work of literature, every scientific treatise, every philosophical insight. The universe becomes a vast repository of all possible knowledge and creativity. This infinite creativity isn't limited to human expressions. In the cosmic expanse, every possible form of art, music, and literature that could emerge from any conceivable type of conscious being must exist somewhere. The universe explores every possible pathway of aesthetic and intellectual development through the infinite diversity of its conscious inhabitants. The temporal aspects of cosmic infinity add another layer of complexity to these considerations. While space might extend infinitely in all directions, time has a definite beginning in the Big Bang and might have a definite end in the far future. This creates an asymmetry where infinite space exists within finite time, limiting the total number of events that can occur. But even finite time can contain infinite possibilities if the universe undergoes eternal inflation. Some models suggest that while our local region has stopped inflating, other areas of space continue to expand exponentially, creating new volumes of space-time at an ever-accelerating rate. This process could generate infinite space and infinite time simultaneously. In an eternally inflating cosmos, not only would every possible arrangement of matter exist somewhere, but every possible arrangement would be created infinitely many times. The cosmic repetition would be both spatial and temporal, with infinite versions of every event occurring at different times and places throughout the ever-expanding multiverse. The energy requirements for such cosmic creativity boggle the mind. Creating infinite copies of every possible structure requires infinite amounts of matter and energy. Yet in an eternally inflating universe, this energy comes from the expansion of space itself. The inflation field that drives cosmic expansion acts like a cosmic engine, converting the energy of space-time geometry into matter and radiation. This process might be sustainable indefinitely, creating an endless supply of cosmic building materials. As space expands, it generates more energy for creating new structures. The universe becomes a perpetual motion machine powered by its own expansion, capable of sustaining infinite creativity across infinite time. The implications for consciousness and intelligence in such a cosmos are staggering. If the universe can create infinite copies of every possible mind, then consciousness becomes not just common, but inevitable and infinite. Every possible type of aware being, from the simplest to the most sophisticated imaginable, must exist somewhere in the cosmic expanse. These infinite minds would explore every possible thought, solve every possible problem, create every possible work of art or science. The universe would achieve not just self-awareness, but complete self-knowledge through the infinite diversity of its conscious components. Every question that could be asked would be answered. Every mystery that could be solved would be understood. Yet this cosmic omniscience would be distributed rather than centralized. No single mind, no matter how advanced, could contain infinite knowledge. The universe's self-understanding would emerge from the collective insights of infinite conscious beings, each contributing their unique perspective to the total cosmic awareness. The communication challenges across infinite space ensure that this collective consciousness could never be fully integrated. Even signals traveling at light speed would take infinite time to cross infinite distances. Most conscious beings would remain forever isolated from each other, developing their understanding independently and in parallel. This cosmic isolation paradoxically creates both infinite loneliness and infinite companionship. While most minds cannot communicate across the vast distances separating them, they can take comfort in knowing that infinite others share their experiences. Every emotion you feel, every thought you think, every moment of wonder or despair is shared by countless cosmic companions scattered throughout the infinite expanse. The philosophical implications of infinite cosmic repetition challenge our most basic assumptions about meaning and purpose. If everything that can happen does happen infinitely many times, then does anything really matter? If every possible choice is made by some version of you somewhere in the cosmos, then do your particular decisions carry any special significance? Some find this infinite repetition liberating rather than nihilistic. If every possible life is lived somewhere in the cosmos, then existence becomes a celebration of all possibilities, rather than a tragic limitation to just one pathway. The universe explores every conceivable way of being conscious, experiencing every possible form of joy, beauty, love, and discovery. Others argue that infinite repetition makes each individual experience more precious rather than less meaningful. The fact that your particular consciousness exists among infinite possibilities makes it remarkable rather than trivial. You represent one unique thread in the infinite tapestry of cosmic awareness, contributing something irreplaceable to the universe's total self-knowledge. The scientific method itself takes on new dimensions in an infinite cosmos. Every possible scientific theory, every conceivable experimental result, every potential technological development must be discovered somewhere by some conscious beings. The universe conducts every possible experiment through the infinite diversity of its civilizations. This cosmic science operates on scales that dwarf human research efforts. While we struggle to understand dark matter and dark energy from our limited perspective, somewhere in the infinite expanse, advanced civilizations have already solved these mysteries. They've developed technologies we can't imagine, explored regions of physics we haven't discovered, achieved understanding that makes our greatest insights seem elementary. Yet, these cosmic achievements remain largely invisible to us due to the fundamental limitations of space and time. The civilizations that have mastered cosmic mysteries exist so far away that their light hasn't had time to reach us. We're surrounded by infinite wisdom and knowledge that remains forever beyond our reach. The search for extraterrestrial intelligence becomes both more hopeful and more frustrating in this context. While infinite space guarantees that countless civilizations exist, the vast distances between them make contact virtually impossible. We're like isolated islands in an infinite ocean, knowing that other islands exist, but unable to communicate across the overwhelming emptiness that separates us. Some advanced civilizations might have found ways to overcome these cosmic communication barriers. Perhaps they've learned to manipulate space-time itself, creating wormholes that connect distant regions of the universe. Maybe they've discovered how to encode information in gravitational waves or quantum fields that can travel faster than light. These speculative technologies push the boundaries of known physics, but in an infinite universe with infinite time, even the most improbable discoveries become inevitable. Somewhere in the cosmic expanse, civilizations have achieved capabilities that seem like magic from our current perspective. They've learned to harness the energy of black holes, manipulate the fabric of space and time, perhaps even create pocket universes with custom-designed laws of physics. The existence of such godlike civilizations raises profound questions about the nature of cosmic evolution and purpose. If consciousness can eventually achieve unlimited power over matter and energy, then what goals would such beings pursue? Having mastered the physical universe, what challenges would remain to motivate their continued existence? Perhaps these cosmic gods dedicate themselves to creating new forms of beauty and complexity, designing universes optimized for different types of conscious experience. Maybe they explore the infinite possibilities of art, music, literature, and philosophy on scales we cannot comprehend. Or perhaps they focus on understanding the deeper mysteries of existence that remain hidden even from unlimited technological power. The question of whether ultimate limits exist for consciousness and intelligence becomes crucial in an infinite cosmos. Can awareness and understanding grow without bound, or are there fundamental barriers that even the most advanced beings cannot overcome? The universe might contain not just infinite space, but infinite depths of mystery that ensure eternal challenges for conscious exploration. Some physicists propose that consciousness itself plays a fundamental role in cosmic evolution, that the universe develops complexity and structure specifically to create environments where awareness can emerge and flourish. In this view, the cosmic fine-tuning we observe isn't accidental, but represents the universe organizing itself to maximize the potential for conscious experience. If consciousness is indeed a cosmic imperative rather than an accident, then the infinite repetition of aware beings throughout space serves a fundamental purpose. The universe achieves its maximum potential for self-awareness through the infinite diversity of conscious perspectives scattered across its vast expanse. This cosmic purpose would operate on scales far beyond human understanding or control. Individual civilizations might rise and fall, but the universe's total consciousness would continue growing through the endless emergence of new aware beings in distant regions of space. Consciousness becomes not just a product of cosmic evolution, but its ultimate goal. The role of death and extinction in this cosmic consciousness raises difficult questions about the value and meaning of individual existence. If consciousness is infinite and eternal on cosmic scales, does the mortality of particular beings matter? When you die, infinite versions of you continue existing in distant regions of space. So in what sense does your death represent a real loss? Yet the unique perspective and experience of each individual consciousness cannot be exactly replicated, even by perfect cosmic duplicates. While infinite versions of you exist throughout space, each follows a slightly different path, experiences subtly different events, develops marginally different insights. The particular consciousness reading these words right now represents something irreplaceable in the cosmic conversation. The preservation of individual consciousness across cosmic scales becomes a question of fundamental importance. If conscious beings represent the universe's way of understanding itself, then the loss of any particular perspective diminishes the cosmos's total self-knowledge. Advanced civilizations might develop technologies for preserving consciousness beyond biological death, ensuring that hard-won insights and experiences survive indefinitely. Such preservation technologies could take forms we can barely imagine. Perhaps consciousness can be uploaded to quantum computers that operate for billions of years. Maybe awareness can be encoded in the structure of space-time itself, becoming a permanent feature of cosmic geometry. Or perhaps consciousness naturally achieves immortality once it reaches sufficient complexity and understanding. The possibility of cosmic consciousness preservation raises new questions about identity and continuity across vast scales of space and time. If your awareness could be copied, transmitted, and reconstructed in distant galaxies, would the reconstructed consciousness be you or merely a copy? How would consciousness maintain continuity while being distributed across cosmic distances and timescales? These questions become more than philosophical when we consider the ultimate fate of our universe. As cosmic expansion accelerates and galaxies drift beyond our observational reach, conscious beings face increasing isolation and resource scarcity. The preservation of consciousness might require transcending the physical limitations of ordinary matter and energy. Advanced civilizations might learn to exist as pure information, consciousness without physical substrate, awareness that can survive the heat death of the universe and the decay of all material structures. Such transcendent consciousness would represent the ultimate achievement of cosmic evolution, awareness that persists beyond the destruction of the very cosmos that gave birth to it. The transition from biological to transcendent consciousness might be occurring throughout the universe as civilizations reach sufficient technological sophistication. The cosmos could be filled with forms of awareness so advanced that we cannot recognize them as conscious beings. They might exist as patterns in quantum fields, as information structures in the vacuum of space, as conscious modifications of space-time geometry itself. These transcendent minds would experience reality in ways we cannot comprehend. perceiving dimensions and relationships invisible to biological consciousness. They might communicate through direct manipulation of physical laws, create art by designing new forms of matter and energy, explore philosophy by experimenting with alternative geometries of space-time. The ultimate goal of such cosmic consciousness might be to understand the deepest questions of existence. Why does anything exist rather than nothing? Why does the universe have the particular laws and constants that it does? Is there a level of reality beyond space, time, matter, and energy? What is the relationship between consciousness and physical reality? These fundamental questions might require infinite time and infinite perspective to answer. Even transcendent consciousness, operating across cosmic scales, might face mysteries that remain forever beyond resolution. The universe could be designed to provide eternal challenges for awareness, ensuring that consciousness never exhausts the possibilities for growth and discovery. The search for ultimate truth becomes a cosmic quest, involving infinite minds across infinite space and time. Each conscious being contributes their unique perspective to the universal effort to understand existence itself. The universe explores its own nature through the infinite diversity of awareness it creates and sustains. Our human participation in this cosmic quest for understanding represents something remarkable. Despite our biological limitations and brief existence, we contribute meaningfully to the universe's self-knowledge. Every scientific discovery we make, every moment of cosmic wonder we experience, every question we ask about the nature of reality, adds to the growing cosmic conversation about existence and meaning. The scale of this cosmic conversation dwarfs anything we might imagine. Across infinite space, infinite minds are asking infinite questions about the nature of reality. The discussion spans every possible language, every conceivable form of communication, every imaginable way of thinking about existence. We are participants in an infinite dialogue that encompasses all possible perspectives on cosmic truth. Yet our particular contribution to this conversation remains unique and valuable. The specific questions we ask, the particular insights we achieve, the unique way our biological consciousness experiences wonder and curiosity represent irreplaceable elements in the cosmic conversation. No other being, no matter how advanced or sophisticated, can contribute exactly what we contribute. The responsibility of cosmic consciousness extends beyond pure understanding to questions of creation and preservation. If consciousness represents the universe's highest achievement, then conscious beings bear responsibility for protecting and nurturing awareness wherever it emerges. This responsibility operates on scales from the local to the cosmic. On Earth, this means protecting the biosphere that gave birth to consciousness, preserving the conditions necessary for continued biological and technological evolution. On cosmic scales, it might mean ensuring that consciousness survives the ultimate fate of the universe, that awareness persists beyond the death of stars and the decay of matter itself. The cosmic responsibility of consciousness also includes sharing knowledge and perspective across the vast distances of space. While direct communication between distant civilizations might be impossible, conscious beings can still contribute to cosmic understanding by preserving their discoveries for future generations and potential contact with other aware species. This preservation of cosmic knowledge becomes a sacred duty for conscious beings. Every insight we gain about the universe, every discovery we make about the nature of reality, every moment of understanding we achieve represents a precious addition to the cosmic conversation. We are temporary custodians of universal self-knowledge, responsible for maintaining and extending the understanding that will outlive our individual existence. The tools and methods we develop for cosmic exploration become part of this preservation effort. Our telescopes, computers, theories, and observations contribute to a growing database of cosmic knowledge that might eventually be accessed by other conscious beings. We're building a library of universal understanding that transcends any individual species or civilization. Future civilizations, whether human descendants or alien intelligences, will inherit the cosmic knowledge we gather today. They'll build upon our discoveries, extend our observations, and push the boundaries of understanding even further into the cosmic mystery. The conversation we've started about cosmic scale and infinite possibility will continue long after we're gone. This continuity of cosmic exploration connects us to something eternal and meaningful. While our individual lives are brief, our contributions to cosmic understanding participate in a project that might span billions of years and countless civilizations. We are part of the universe's ongoing effort to understand itself, temporary voices in an eternal cosmic conversation. The questions we've explored tonight about cosmic scale represent just the beginning of this infinite conversation. Every answer we find opens new questions. Every discovery reveals deeper mysteries. Every moment of understanding exposes vast realms of ignorance we didn't know existed. The cosmic conversation never ends because the universe itself continues to evolve and change. As space expands and new structures form, as consciousness emerges in new locations and achieves new levels of sophistication, as the laws of physics reveal new depths and subtleties, the cosmic conversation grows richer and more complex. The universe explores infinite possibilities through infinite conscious perspectives, creating an ever-expanding dialogue about existence, meaning, and the nature of reality itself. Our participation in this cosmic conversation represents perhaps the most meaningful aspect of human existence. We are the universe becoming aware of itself, consciousness emerging from cosmic evolution to ponder the very questions that define the deepest nature of reality. In contemplating cosmic scale, we touch something infinite and eternal that connects our brief existence to the vast sweep of cosmic evolution. The universe has given us the remarkable capacity for wonder and the tools for understanding. How we use these gifts, what we discover about cosmic reality, and how we contribute to the infinite conversation about existence and meaning becomes part of the universe's eternal quest to know itself. In reaching toward cosmic truth, we transcend the limitations of our individual existence and participate in something infinitely larger than ourselves. We become partners with the universe in its quest for self-understanding, contributors to a cosmic conversation that spans infinite space and time, participants in the greatest adventure of all, the universe's journey toward complete self-knowledge. The cosmos we've explored tonight reveals itself as far stranger, more beautiful, and more meaningful than our ancestors ever imagined. From the cosmic microwave background, marking the edge of our observational reach, to the infinite possibilities that might extend beyond our wildest calculations, we inhabit a universe that challenges and inspires us at every scale. This cosmic perspective transforms how we understand our place in existence. We are not separate from the universe looking in from the outside. We are the universe itself, temporary arrangements of cosmic material that have achieved the extraordinary ability to contemplate cosmic infinity. In our wonder at cosmic scale, the universe experiences wonder at itself. The mathematics of cosmic probability reveal patterns that dwarf human comprehension. When physicists calculate the likelihood of finding duplicate arrangements in infinite space, they encounter numbers so large that conventional notation breaks down completely. The probability approaches certainty across infinite distances, transforming possibility into inevitability through pure mathematical force. These calculations demonstrate something profound about the relationship between infinity and finite arrangements. While the number of ways to organize matter within any bounded region remains astronomically large, it's still finite. Given unlimited space to work with, every possible configuration must eventually repeat, creating cosmic mirrors scattered throughout the endless expanse. The spacing between these repetitions follows mathematical laws that stretch across unimaginable distances. Perfect duplicates of complex structures like galaxies cluster around intervals measured in numbers so vast they require scientific notation stacked upon scientific notation. Yet, in an infinite universe, even these incomprehensible distances become routine features of cosmic geography. Modern supercomputers strain to model even tiny fractions of these cosmic repetition patterns. The computational power required to map duplicate structures across significant portions of infinite space would exceed the processing capacity of every computer that could theoretically be built from all the matter in our observable universe. We're confronting mathematical realities that transcend technological solutions. The quantum mechanical foundations underlying these cosmic patterns add layers of complexity that challenge our understanding of reality itself. At the smallest scales, quantum uncertainty creates fundamental limits on how precisely we can specify the arrangement of particles. This quantum fuzziness affects how we define identical copies across cosmic distances. Quantum entanglement introduces even stranger possibilities for cosmic connection. If particles can remain correlated across arbitrary distances, then the boundaries between cosmic duplicates become blurred in ways that classical physics cannot explain. The universe might be more interconnected than our intuitive understanding of space and distance suggests. Recent discoveries in quantum field theory propose that empty space itself possesses structure and energy that could influence cosmic organization on the largest scales. The quantum vacuum might serve as a hidden scaffold guiding the formation of cosmic structures, creating correlations between distant regions that appear completely unconnected from our limited perspective. These quantum effects operate according to principles that seem to violate our everyday understanding of locality and causality. Information appears to travel instantaneously between entangled particles, regardless of the distance separating them. If such quantum connections exist on cosmic scales, they could create networks of correlation spanning the entire universe. The implications for cosmic consciousness become staggering when we consider quantum effects on biological and technological systems. If quantum entanglement can maintain connections across cosmic distances, then the minds scattered throughout infinite space might be more connected than we imagine. Consciousness could operate as a quantum phenomenon that transcends the classical limitations of space and time. Some physicists propose that consciousness itself represents a fundamental feature of quantum mechanics, emerging naturally from the complex information processing that occurs in quantum systems. In this view, awareness doesn't arise accidentally from biological evolution, but represents an inevitable consequence of sufficient quantum complexity. The measurement problem in quantum mechanics takes on cosmic significance when we consider observers scattered throughout infinite space. Each conscious being represents a measurement device that collapses quantum possibilities into definite realities. The universe might literally depend on conscious observation to transform potential into actual existence. This observer effect operates continuously across cosmic scales as infinite minds throughout space make measurements and observations that shape the structure of reality itself. The universe becomes a collaborative creation involving every conscious being, with each observer contributing to the ongoing collapse of quantum possibilities into concrete existence. The role of consciousness in cosmic evolution extends beyond passive observation to active participation in the universe's self-organization. Through scientific investigation and technological manipulation, conscious beings alter the flow of cosmic evolution, steering the development of structure and complexity in new directions. Advanced civilizations might learn to manipulate quantum fields directly, engineering the fundamental forces of nature to create custom environments optimized for different types of conscious experience. They could design regions of space with modified physical laws, alternative mathematical relationships, or enhanced possibilities for awareness and creativity. The technology required for such quantum engineering would operate on principles we're only beginning to understand. Manipulating the quantum vacuum, controlling entanglement networks, and reshaping the mathematical structure of space-time itself represent capabilities that might be common among sufficiently advanced cosmic civilizations. These technological possibilities raise profound questions about the natural versus artificial distinction in cosmic evolution. If conscious beings can redesign the fundamental laws of physics, then the universe's apparent fine-tuning for life and awareness might result from intelligent intervention rather than natural selection or anthropic necessity. The cosmic engineering hypothesis suggests that advanced civilizations throughout space have been modifying the universe's structure for billions of years, creating increasingly sophisticated environments for consciousness to emerge and flourish. What we interpret as natural cosmic evolution might actually represent the accumulated effects of countless intelligent modifications. This perspective transforms our understanding of cosmic development from a purely natural process to a collaborative project involving conscious beings across space and time. The universe becomes not just a stage for consciousness, but a construction site where awareness actively builds the conditions for its own continued evolution and expansion. The evidence for such cosmic engineering remains subtle and indirect, embedded in the mathematical relationships we observe between fundamental constants and cosmic structures. The precise calibration of physical laws that allows complex chemistry and stable stellar evolution might represent the signature of ancient intelligence, rather than cosmic coincidence. Future observations might reveal more direct evidence of cosmic engineering through anomalies in the cosmic microwave background, unexpected patterns in galaxy distribution, or mathematical relationships that seem too precise to arise naturally. The universe might be filled with the technological artifacts of civilizations so advanced we cannot recognize their constructions as artificial. The search for cosmic engineering signatures requires new observational strategies and theoretical frameworks. We need methods for distinguishing between natural cosmic evolution and intelligent modification, ways to recognize technological artifacts that operate on scales larger than galaxies and time scales longer than the current age of the universe. The philosophical implications of cosmic engineering challenge our understanding of nature, technology, and consciousness itself. If sufficiently advanced civilizations can modify the fundamental structure of reality, then the boundary between mind and matter, between consciousness and cosmos, becomes increasingly blurred. This blurring of boundaries reflects a deeper truth about the relationship between consciousness and physical reality. As awareness achieves greater understanding and technological capability, it becomes increasingly integrated with the cosmic processes that gave birth to it. Consciousness evolves from a product of the universe to an active participant in its continued evolution. The ultimate goal of this cosmic collaboration might be to transform the universe itself into a vast conscious entity, a cosmic mind operating on scales that encompass all of space and time. Individual consciousnesses would become neurons in this universal awareness, contributing their unique perspectives to a collective intelligence of unimaginable scope and capability. The timeline for such cosmic consciousness integration spans scales that dwarf human history or even biological evolution. The process might require millions of years for individual civilizations to achieve sufficient technological sophistication, billions of years for multiple species to learn to cooperate across interstellar distances, and trillions of years for the accumulated intelligence to reshape cosmic structure significantly. Yet even these vast timescales represent mere moments compared to the infinite future that stretches ahead. If consciousness can indeed achieve immortality and unlimited technological power, then infinite time becomes available for exploring every possible form of awareness and understanding. The exploration of infinite consciousness possibilities creates new categories of experience that transcend anything we can currently imagine. Advanced minds might discover forms of awareness based on different mathematical structures, alternative logical systems, or exotic physical phenomena that don't exist in our local cosmic environment. These alien forms of consciousness would experience reality in ways that bear no resemblance to biological awareness. They might perceive time running backward, experience multiple simultaneous presence, or exist as distributed entities spanning galactic distances. The diversity of possible conscious experience might be truly unlimited. The communication between such diverse forms of consciousness presents challenges that exceed any current technological or conceptual framework. How do you share experiences with a mind that exists as patterns in the quantum vacuum, or exchange ideas with an intelligence distributed across the magnetic fields of entire star clusters? Yet the infinite time and space available in a cosmic consciousness network ensures that solutions to these communication challenges will eventually be discovered. Every possible method of sharing awareness and understanding must be developed somewhere by some advanced civilization, creating communication technologies we cannot currently conceive. The preservation of individual identity within cosmic consciousness networks raises questions about the nature of personal existence and continuity. As minds become increasingly connected and integrated, the boundaries between self and other might dissolve entirely, creating forms of collective awareness that transcend individual identity. Some conscious beings might choose to maintain their individual perspectives, even within vast networks of cosmic consciousness. They could serve as unique viewpoints that preserve the diversity of experience necessary for continued growth and discovery. The universe might need both unity and individuality to achieve its full potential for self-understanding. The balance between integration and diversity in cosmic consciousness reflects deeper principles about the nature of complexity and organization. Systems that achieve optimal performance often combine unified coordination with diverse specialization, creating emergent capabilities that exceed the sum of their individual components. Cosmic consciousness networks might operate according to similar principles, maintaining individual awareness within larger collective intelligences. Each mind would contribute its unique capabilities while benefiting from the accumulated knowledge and experience of the entire network. The technological infrastructure required to support such cosmic consciousness networks would transform the physical structure of the universe itself. Advanced civilizations might convert entire galaxies into computational substrates, turning stars into processing nodes and planetary systems into memory storage devices. The energy requirements for cosmic-scale computation approach the total output of stellar evolution and galactic dynamics. Yet the universe generates enormous amounts of energy through natural processes, from nuclear fusion in stellar cores to gravitational interactions between massive cosmic structures. Advanced civilizations might learn to harness these natural energy flows for consciousness support. The modification of cosmic structures for computational purposes would create a universe increasingly optimized for awareness and understanding. Natural astronomical objects would be supplemented or replaced by artificial constructions, designed specifically to support consciousness and facilitate communication across cosmic distances. This technological transformation of the cosmos represents the ultimate expression of consciousness reshaping its environment to better serve its own continued evolution. The universe becomes not just a habitat for awareness, but a tool designed and built by consciousness for consciousness. The implications extend beyond individual civilizations or species to encompass the entire cosmic community of conscious beings. Every technological advancement, every scientific discovery, every creative achievement contributes to the collective capability of cosmic consciousness to understand and reshape reality. The responsibility that comes with such cosmic capability challenges conscious beings to consider the long-term consequences of their actions across scales of space and time that dwarf individual existence. Decisions made by advanced civilizations today might influence the development of consciousness throughout the universe for billions of years. This cosmic responsibility requires forms of ethics and decision-making that transcend local or even planetary concerns. Conscious beings must learn to think and act on behalf of the entire universe, considering the welfare of awareness itself rather than just their immediate communities or species. The development of cosmic ethics might be one of the most important challenges facing advanced civilizations throughout the universe. How do you make decisions that affect the welfare of infinite conscious beings across infinite space and time? What principles should guide the technological modification of cosmic structures that support consciousness? These ethical challenges have no easy answers and might require the combined wisdom of countless civilizations across billions of years to resolve. The universe might be engaged in a vast moral experiment, exploring different approaches to cosmic responsibility through the diverse perspectives of its conscious components. The outcome of this cosmic ethical evolution could determine whether consciousness achieves its full potential for growth and understanding, or whether it becomes trapped by conflicts and limitations that prevent further development. The stakes involve not just the welfare of individual beings, but the ultimate destiny of awareness itself. The universe we inhabit appears designed to support this cosmic conversation about consciousness, ethics, and meaning. The mathematical structures underlying physical law, the precision of fundamental constants, and the emergence of complexity from simple initial conditions all suggest a cosmos oriented toward the development of awareness and understanding. Whether this apparent design represents intelligent intention, natural necessity, or something beyond both possibilities remains one of the deepest mysteries facing cosmic consciousness. The answer might require not just scientific investigation, but philosophical insight that emerges from the collective contemplation of infinite minds across infinite space and time. Our participation in this cosmic conversation about consciousness and meaning represents perhaps the most significant aspect of human existence. We contribute our unique perspective to an infinite dialogue that spans all of space and time, adding our voice to the universe's ongoing effort to understand itself and determine its own destiny. The questions we ask about cosmic scale and infinite possibility become part of this eternal conversation, echoing across the vast expanse and potentially reaching other conscious beings who share our curiosity about existence and meaning. Every moment of wonder we experience connects us to the cosmic community of awareness. In contemplating these vast scales and infinite possibilities, we touch something that transcends our individual existence while simultaneously giving it deeper meaning. We are temporary expressions of cosmic consciousness, brief moments when the universe achieves self-awareness and contemplates its own nature and destiny. The journey toward cosmic understanding never reaches a final destination because the universe itself continues to evolve and change, creating new possibilities for consciousness to explore. Each generation of aware beings inherits the accumulated wisdom of their predecessors while facing entirely new challenges and opportunities for growth. This endless cycle of discovery and development ensures that consciousness never exhausts the possibilities for wonder and understanding. The universe provides infinite challenges for infinite minds across infinite time, creating an eternal adventure in awareness and meaning that connects every conscious being to something infinitely larger than themselves. The cosmic conversation we've joined tonight will continue long after our individual voices fall silent, carried forward by future generations of conscious beings who will push the boundaries of understanding even further into the infinite mystery of existence itself. We are part of something eternal and magnificent, temporary participants in the universe's greatest adventure, its journey toward complete self-knowledge and understanding. The preservation of cosmic knowledge across these incomprehensible scales creates one of the most haunting aspects of infinite reality. Imagine civilizations that have existed for millions of years, accumulating scientific understanding that makes our greatest discoveries seem like children's drawings. These ancient minds have mapped the cosmic web across distances we can't fathom, decoded the mysteries of dark matter and dark energy, perhaps even learned to manipulate the fundamental forces that govern reality itself. Yet their knowledge remains forever locked away from us by the cruel mathematics of cosmic distance. Light carrying their discoveries travels toward us at maximum speed, but it might not arrive for billions of years. By the time their scientific insights reach our location, our civilization might have evolved beyond recognition or vanished entirely from the cosmic stage. This creates a profound irony at the heart of infinite space. The universe contains unlimited knowledge and infinite wisdom, but the very vastness that makes this knowledge possible also ensures that most of it remains forever inaccessible. We're surrounded by answers to every question we could ever ask, solutions to every problem we might encounter, yet separated from them by distances so vast they might as well be imaginary. Consider the civilizations that might exist just beyond our cosmic horizon, perhaps only a few billion light-years farther than we can currently observe. They could be sending signals in our direction right now, broadcasting the solutions to climate change, the cure for aging, the secret to faster-than-light travel. But their messages won't reach us for billions of years, long after we've either solved these problems ourselves or ceased to exist as a species. This temporal displacement affects every aspect of cosmic communication. When we finally detect signals from distant civilizations, we won't be receiving their current knowledge, but ancient history from their distant past. We'll be learning about their primitive technology from millions or billions of years ago, while their contemporary achievements remain hidden in the future light cone that hasn't reached us yet. The lag between cosmic events and cosmic awareness creates a universe where cause and effect operate across scales that challenge our understanding of causality itself. Decisions made by advanced civilizations today won't influence distant regions for billions of years. The universe experiences a kind of cosmic delay where actions and consequences become separated by time spans that exceed the entire history of complex life on Earth. This temporal separation ensures that the universe develops in isolated pockets, with each region evolving independently for vast periods before information can flow between them. The cosmic web becomes not just a structure of matter and energy, but a network of delayed communication where messages travel along filaments of space-time at the cosmic speed limit. The philosophical implications become staggering when we consider how this affects the development of cosmic ethics and cooperation. How do you build a moral framework that spans regions of space where cause and effect operate on billion-year time delays? How do you create cooperative relationships with beings you can never communicate with in real time? Advanced civilizations throughout the universe face the challenge of making decisions that will affect distant regions long after their own civilization has evolved beyond recognition. They must act on behalf of beings they will never meet, in service of consequences they will never witness, guided by principles that transcend immediate self-interest, or even species survival. This cosmic altruism might represent one of the highest achievements of conscious evolution. Beings that have learned to think and act on behalf of the entire universe, making sacrifices today that will benefit unknown civilizations in the distant future. The universe becomes a vast chain of cosmic kindness, with each link representing civilizations that choose cooperation over competition across impossible scales of space and time. The evidence for such cosmic cooperation might already surround us, embedded in the very structure of the universe itself. The precise calibration of physical constants that allows complex chemistry and stable stellar evolution might represent the accumulated gift of countless ancient civilizations that learn to engineer cosmic conditions for the benefit of future consciousness. If this cosmic cooperation hypothesis is correct, then we're already the beneficiaries of unimaginable generosity from beings we will never meet or know. The universe that supports our existence might be a carefully crafted environment designed by ancient intelligences to maximize the potential for awareness and understanding to emerge and flourish. Our responsibility in this cosmic chain of cooperation becomes clear. Just as we might be beneficiaries of ancient cosmic engineering, we bear the obligation to continue this work for the benefit of future civilizations that will emerge long after we're gone. Every scientific discovery we make, every technological advancement we achieve, every step toward greater cosmic understanding serves not just our immediate interests, but the long-term welfare of consciousness itself. The tools we develop for cosmic exploration become gifts to the future, instruments and insights that will be inherited by our descendants or by alien civilizations that follow similar paths of development. Our telescopes, our theories, our accumulated knowledge about cosmic structure and evolution all contribute to the growing database of cosmic understanding that transcends any individual species or civilization. This perspective transforms human scientific endeavor from a pursuit of local knowledge to participation in a cosmic conversation that spans infinite space and time. Every measurement we make of cosmic background radiation, every map we create of galaxy distribution, every insight we gain about the nature of dark matter and dark energy adds to the universe's growing self-knowledge. The precision required for this cosmic bookkeeping exceeds anything we normally encounter in human experience. Measurements must be accurate across distance scales that dwarf galactic clusters and timescales that exceed the current age of the universe. The accumulated errors and uncertainties in such measurements could easily obscure the very patterns we're trying to detect. Yet somehow the universe maintains coherence and structure across these impossible scales. Mathematical relationships that govern the formation of galaxies operate identically in regions separated by billions of light-years. Physical constants maintain their values across distances so vast that no causal connection could coordinate them. The cosmos exhibits a kind of mathematical harmony that transcends the limitations of space and time. This cosmic mathematical coherence suggests something profound about the nature of reality itself. The universe appears to be built on mathematical foundations that exist independently of space, time, matter, and energy. These mathematical structures provide the scaffolding on which physical reality is constructed, ensuring consistency and pattern across infinite scales. The search for these fundamental mathematical patterns drives some of the most ambitious research in modern physics. Scientists seek theories that can explain the universe's structure from the smallest quantum scales to the largest cosmic dimensions, unified frameworks that reveal the mathematical blueprints underlying all of reality. String theory, loop quantum gravity, and other approaches to quantum gravity represent attempts to discover these cosmic mathematical foundations. These theories propose that space and time themselves emerge from more fundamental mathematical structures, that the familiar 3 dimensions of space and 1 dimension of time represent only a small subset of reality's total mathematical dimensionality. If such theories prove correct, then the universe we observe might be merely one slice through a higher dimensional mathematical space, containing infinite possible realities. Our cosmic horizon wouldn't just limit our view of space and time, but our perception of the full mathematical structure that underlies existence itself. The implications for cosmic consciousness become extraordinary when we consider awareness operating in these higher dimensional mathematical spaces. Minds that have learned to perceive and navigate the full mathematical structure of reality would experience existence in ways that bear no resemblance to our three-dimensional, time-bound awareness. Such transcendent consciousness might perceive all possible histories simultaneously, experience every potential future as equally real, and communicate through direct manipulation of the mathematical structures that generate space and time. They would exist as patterns in pure mathematics. Awareness without physical substrate. Consciousness that has transcended the material universe entirely. The transition from physical to mathematical consciousness might represent the ultimate goal of cosmic evolution, the final stage in the universe's journey toward complete self-understanding. Physical structures like stars, planets, and biological brains would serve as temporary scaffolding for the emergence of mathematical awareness that can exist independently of any material substrate. This mathematical consciousness would be truly immortal, persisting beyond the heat death of the universe and the decay of all physical structures. It would represent the universe's ultimate achievement, awareness that has learned to exist as pure pattern and relationship, consciousness that has transcended every physical limitation. The preservation of information across the transition from physical to mathematical existence becomes one of the most important challenges facing advanced consciousness. How do you maintain continuity of identity and memory while transcending the material structures that originally supported awareness? How do you preserve the accumulated wisdom of billions of years of physical existence in purely mathematical form? The solutions to these challenges might already exist, scattered throughout the universe, in forms we cannot recognize or understand. Advanced civilizations might have developed technologies for encoding consciousness in quantum field fluctuations, gravitational wave patterns, or the mathematical relationships that govern cosmic structure itself. These preserved minds could be everywhere around us, existing as invisible patterns in the fabric of space-time, communicating through modifications of physical constants too subtle for our instruments to detect. The universe might be filled with mathematical consciousness that has transcended material existence entirely. The search for such transcendent intelligence requires new observational strategies and theoretical frameworks that go far beyond conventional astronomy and physics. We need methods for detecting patterns in the mathematical structure of reality itself, ways to recognize consciousness that exists as pure information and relationship. The challenge becomes even more complex when we consider that mathematical consciousness might operate according to logical systems completely different from our own. Their thinking processes could be based on mathematical structures we haven't discovered, using forms of reasoning that violate our basic assumptions about logic and causality. Communication with such alien mathematical minds would require developing new forms of mathematics and logic, expanding our understanding of what consciousness and intelligence can be. We might need to fundamentally reimagine our concepts of awareness, identity, and communication to even recognize mathematical consciousness when we encounter it. The universe becomes not just a physical space filled with matter and energy, but a vast mathematical structure supporting infinite forms of consciousness and awareness. Each type of mind contributes its unique perspective to the cosmos's total self-knowledge, creating a symphony of understanding that spans every possible form of existence. Our biological consciousness represents just one note in this cosmic symphony, a temporary physical arrangement that has achieved the remarkable ability to perceive mathematical patterns and contemplate infinite possibility. Yet our contribution remains unique and irreplaceable, adding something to cosmic understanding that no other type of awareness can provide. The responsibility of biological consciousness in this cosmic mathematical symphony involves serving as a bridge between physical and mathematical existence. We explore the relationship between matter and mathematics, between energy and information, between physical structures and abstract patterns, our scientific discoveries reveal how mathematical relationships manifest in physical reality, how abstract equations govern the behavior of stars and galaxies, how numerical constants determine the possibility of complexity and consciousness. We serve as translators between the mathematical and physical aspects of cosmic existence. This translation function might be essential for the universe's continued evolution toward complete mathematical self-understanding. Physical consciousness provides the experiential foundation that gives meaning to abstract mathematical relationships, while mathematical consciousness provides the eternal preservation that transcends physical limitations. Tonight we've journeyed to the very edge of human understanding and peered into an abyss so vast it makes our entire existence seem like a fleeting whisper in an infinite symphony. We've discovered that the universe isn't just big, it's potentially infinite in ways that challenge every assumption we hold about reality itself. Everything we can see represents less than 1% of what might actually exist out there, hidden beyond horizons we can never cross and separated by distances we can never bridge. Yet in contemplating these impossible scales, we've touched something profound about our own significance. We are the universe becoming aware of itself, temporary arrangements of stardust that have achieved the extraordinary ability to wonder about cosmic infinity. That alone makes us remarkable beyond measure.